BABS, or Ballistic Absorption Barrier Systems, utilize recycled scrap tires to create blast absorption barriers for use in perimeter and checkpoint security, embassy fortification, pipeline protection, and major event security. Scrap tires are one of the world's largest environmental problems, causing storage and disposal issues, as well as pollution and health concerns. Tire piles are prevalent throughout the world. However, many current applications for scrap tires involve burning the tires for energy or shredding the tires to put into landfills, both of which cause long-term environmental issues. Terrorist attacks and war zone activities are a growing problem causing major disruptions to everyday activities worldwide. BABS blocks have been developed and created as a solution to help with both of these international problems. BABS blocks can be custom-made and installed for each specific and unique application. The basic concept is to utilize the polymeric properties of the base material to deflect and absorb energy in a form that is easy to move and to stack. Here you see some conceptual models for perimeter protection, building protection, and pipeline protection. These are some of the many applications for the ballistic absorption barrier system. The standard BABS block is 3 foot or approximately 1 meter tall and 6 foot or approximately 2 meters wide. BABS blocks can be stacked to create a wall formation. The EcoBlock is another product constructed from recycled scrap rubber tires. The EcoBlock is similar in size to 2 sandbags and weighs 30 pounds or 13.6 kgs. The EcoBlock is very portable, stackable, and reusable. EcoBlocks are designed to interlock, and they have vertical holes to allow for the ability to stake them together or into the ground for added strength. EcoBlocks are used for flood protection, erosion control, as well as small blast and ballistic events. In the picture on the screen, you can see a wall of EcoBlocks being used for erosion control on a hillside next to a highway system. The EcoBlocks stop the soil from flooding onto the roadway and then can be removed and reused after the erosion problem is resolved. These pictures show the EcoBlock during ballistic testing. Ballistic testing has been performed using a variety of ammunition to measure ballistic resistance. BABS have also been designed for ease of movement and quick deployment. They have been constructed to be positioned similar to building blocks, and they are portable and reusable. The basic BABS block design has been built for quick installation using a lifting system built into the blocks for ease of movement. With the shorter hook system used, the BABS blocks can be moved quickly into precision formations as well as when total operating height is a concern. During installation, BABS blocks can be moved closer together, or after the wall experiences a blast event, any shifted blocks can be repositioned with a forklift or any heavy equipment. The BABS blocks have been tested in repeated blast events without post-test handling, and the blast attenuation has remained consistent behind the wall. The BABS blocks have been tested in conditions with the face of the blocks flush, as well as when the blocks have slightly different depths. Each setup has shown excellent blast absorption and attenuation. BABS wall construction can be built with minimal personnel and the most basic heavy equipment. During installation, BABS blocks can be moved with a hook and chain system for ease of movement and quick installation. BABS can be stacked in different configurations for large and small blast events. Here you can see the cross-section of a configuration for an application where there is an anticipated large blast event. In the summer of 2009, ICI exhibited and tested the BABS product at the FPED 7 Force Protection Equipment Demonstration in Quantico, Virginia, which was sponsored by the U.S. Department of Defense. The BABS was subjected to both blast and ballistic testing during the demonstration. In December of 2009, the BABS product underwent 6 days of blast survivability testing at the U.S. Army Aberdeen Test Center, located at the Aberdeen Proving Grounds in Maryland. BABS test data and details are restricted to personnel with ICI-approved clearance. The test plan was devised in coordination with the U.S. Army Aberdeen Test Center to simulate real-life blast events. The BABS blocks were placed in a wall configuration with a closed end and an open end. The charge was placed at a standoff distance from the center of the wall, and pressure and temperature data was collected in multiple places on the front of the wall, on the back of the wall, and at distances behind the wall. Slow motion video was used to capture the events. On the front of the wall, pressure and temperature gauges were attached to the face with metal pipes and angle iron to protect the sensors from blast debris to allow for accurate data collection. The blast charge was placed on a metal plate on the ground to simulate a worst-case blast event with maximum pressure. Here you see the open side of the wall configuration. This is used to simulate an opening in a perimeter wall application. In the back view, you can see the temperature and pressure sensors on the back of the wall and sensors placed behind the wall to measure the overblast pressures. Here you see the closed side of the wall configuration. This represents a corner of a perimeter wall configuration. On the following two blast videos, you will see a blast event from the side of the wall focusing on the front face, and then the same blast from the back of the wall. The following video will show the energy from the blast as it first occurs, then the fireball will follow behind the displaced air from the blast wave. The metal structures and sandbags will be pushed against the wall as the blast energy makes full impact on the face of the wall. This video shows the same blast from the back of the wall. The camera is positioned so that the top of the screen is flush with the top of the wall. You will see a bright light from the blast, and you will also notice no disturbances or movement to the sensors or sandbags behind the wall. The results from the blast event showed excellent blast attenuation of over 99% at the center of the wall where the blast pressure was the greatest. There was virtually no increase in temperature, and the pressure measured behind the wall was below the human threshold for eardrum rupture. The attenuation on the left and right of the wall was lower due to the lower blast pressure on the front of the wall in the corresponding positions. The following pictures show the blast area and BABS wall after the blast event. The charge used created a hole through the 4-inch steel plate and over 1 foot deep into the concrete below the plate. After the blast event, the BABS wall was intact with only small movements between the blocks from the vibration of the blast. The alignment of the wall was still intact. There was no damage on the back side of the wall. There was no damage on the closed side of the wall. The second blast event was performed with the same wall configuration, but with a closer standoff distance from the blast. The results were similar to the first test, with the BABS wall in place with no disturbances behind the wall. The blast pressure caused the metal pipes protecting the pressure sensors to hit the wall with such force that they were bent. However, no damage occurred to the face of the wall. The blast attenuation was excellent, showing over 99% attenuation at the center of the wall with less than a 3-degree temperature increase measured behind the wall. The next set of testing involved a shape charge RPG positioned in front of the wall. The RPG was positioned at an arming distance from the face of the wall. 16 1-inch steel witness plates were placed in position behind the wall to measure the effectiveness of a BABS block during an RPG blast. The following video shows the ignition of the RPG shape charge and the blast energy and fireball on the face of the wall. The entry point of the RPG charge created a self-healing hole, leaving no line of sight through the wall. The charge penetrated the BABS block and traveled through 2 of the steel witness plates, splashing down on the 3rd plate. The BABS block showed similar capabilities to that of 14 inches of steel in the RPG shape charge testing. Next, the same RPG testing was conducted on a BABS configuration with a depth of 2 standard size BABS blocks. This configuration would be similar to a perimeter wall application. The RPG entered into the second BABS block, stopping at a distance of 6 inches or 15 centimeters. The final set of tests was designed to test the survivability of a BABS wall during multiple blast events. The wall was set in place and 3 blast events were conducted without adjusting, replacing, or moving any blocks between blast events. Additional sensors were added to prove the absorption properties of the BABS wall. If the blast energy was simply being redirected, it would be expected that at a distance behind the wall, there would be an increase in pressure as the redirected energy waves continued along their path. The testing confirmed the absorption properties of the BABS blocks. The collected data showed a reduction in blast pressure as the sensor distance increased behind the wall. This proved that the blast energy was absorbed and not simply redirected. Through all 3 blast events during the repeated survivability testing, the BABS wall not only showed excellent attenuation of over 99%, but also proved that the BABS wall was absorbing blast energy. Nearly identical attenuation results were recorded after all 3 blast events. In April of this year, the BABS and EcoBlock products were displayed at the Counter-Terror Expo in London. Innovative Concepts International utilized this platform to showcase our products to the international community. An advertising campaign was built around the event and specifically in the event guide, where ICI sponsored many high-profile sections for maximum exposure. To best represent the scale of the BABS product, the exhibit booth space was constructed utilizing a wall of 15 BABS blocks and a separate wall of 50 EcoBlocks. Small model displays were also presented along with banner displays and brochures. The overall effect of walking into the corner of the booth surrounded by BABS blocks allowed visitors to feel and hear the effect of the energy absorption properties of the product. Many new contacts were made during the show, and the potential to expand the product line within Europe is very promising. During the exhibit, we were given the opportunity to make a presentation introducing the BABS and EcoBlock products. The presentation was titled Recycle, Reuse, Protect. The presentation was given as a case study explaining the benefits of using recycled rubber scrap tires to produce energy-absorbing products. Between April of this year through July, ICI has placed advertisements in various industry and defense publications. As the product line is able to be used for many applications, the focus has been broad, targeting counter-terrorism, homeland security, United Kingdom Home Office, and port authorities. The following slides show you different applications and conceptual models for the BABS blocks. This model shows you perimeter protection to be used around a building. In this model, you can see the BABS blocks used for pipeline protection. For suspect packages, vehicles, or even airplanes, BABS blocks could be used to mitigate the effects of a blast. The BABS blocks can be custom made and designed for different applications. Here's a perimeter protection application using a different style block.